Hi, my name is Gleb Khrushchev, and I'm a Principal Engineering Manager at Machine Learning Group at Microsoft.
Hi, my name is Ringling Wang. I'm a technical program manager in the same team.
So today we're going to talk about Microsoft ML, which is the ML package for Microsoft R Server. We bring the best of scalable, fast, battle-tested algorithms to the Microsoft R Server. So there are several things that I'm going to talk about today, and one of the key benefits of this package is that we bring fast and scalable machine learning algorithms. And they can be used for a variety of tasks. And we have worked really hard to make them work really well in several areas, specifically with text, also with images. And with this release, we're bringing the cross-platform aspect so that all that technology is now available not only on Windows, but also on Linux, on Spark, and Hadoop. And you can actually scale it out on the cluster. All right, and let's talk about the learners that we have. So imagine that you have a problem where you're trying to separate two classes. In this picture, they're represented in red and blue color. So what you could do, you can kind of draw a line between them, try to fit that line as best as you could to separate it. And that's what linear learners do. We have two of them. We have fast linear and logistic regression. And they also support regularization, which is called L1 and L2, which produces more accurate and the models are more resistant to overfitting. They're very fast to train, the models are very simple, and they can scale to a large amount of data. However, if you're interested more in accuracy and you're trying to do a better job of trying to predict the results, you often would go for boosted trees, and we have or random forests. And we have both FastTree, which is a boosted decision tree, which is similar to XGBoost, and we also have a random forest as well. And finally, there is a GPU-accelerated deep neural net and a one-class SVM. One-class SVM allows you to detect anomalies and find outliers within your data. Now, let's talk a bit about scalability. So one of the issues with the open source R machine learning packages is that they're often limited to one thread, one processor, and are limited to the data that you have. So the advantage of the learners that we offer is that they are able to stream data, meaning that you're not limited to RAM. You can even train a 1 terabyte data set on one machine. You can also are able to train on a very large number of features, actually billions of different features. And that might come in handy if you have a very large product catalog or if you're dealing with natural text where there's a lot of different words or combinations of words you're trying to deal with. But even if you have a scalable algorithm, you also want to make it performant. And so that's why we introduced support for Hadoop and Spark. And so now those algorithms can be distributed on a cluster, and you can reduce the time to train the model. So the very nice thing about it is that you don't have to change the code very much to take advantage of the scalability. You just need to change the context from local to Spark. And also, that would allow you to take advantage of all this hardware. Okay, so now Ringling is going to talk about the text analytics.
Thank you, Gleb.
Yes.
Hi. So there are a lot of scenarios where you can imagine text analytics being very useful. For instance, in the generic text classification case, you can imagine a customer support center receiving tons of support tickets and email phone calls every day. And it will be naturally for them to want to classify them into predefined categories so that it will be easier for the support team to take simple actions on them. And in another case, you can imagine that they want to triage these support tickets based on automatically detecting the severity of them and to detecting whether or not it's likely to get escalated to a higher level of tier support. Another interesting case is sentiment analysis. You can imagine that when a company first launches a new product, they would like to learn about the customer feedback to that product. And one way to do that is to monitoring the social media and to figure out if the tweet for the product was positive or negative in the prospective sentiment. Now, we're able to achieve all of that by leveraging the natural language processing technology from Office and Bing. And so, for instance, you will have access to the same technologies that process millions and billions of web requests on Bing every day, and if you choose our offering. So
I have a question. So now you have this text processing, but it is quite difficult to do sentiment because you have to have all this training data and labels. And how do you do this?
Yes, so that's what I want to talk about next, because that is something that we have been working on a lot in the latest release. So we solve this problem by offering a pre-trained model. So the pre-trained model allows you to get a sentiment score out of the box without having to have any training data. So you can see in the code snippet below, you can very easily get a sentiment score with a very simple few lines of code. And the model is very high quality because it is the same model that you will get from the cognitive service sentiment analysis service. The model also uses deep neural network technologies in the process of training. And this is a technology that we have obtained from Microsoft Research in Asia. And finally, you can adopt this model to a custom domain by using the pre-trained model score as a feature and train the model on your domain data. So Gleb, so far, so much about the text analytics. Would you like to talk more about images?
Thanks, Ringling. So image featurization and processing of images comes in a variety of situations. Often you're trying to find a product in a catalog and you don't know what it's called, but you know what it looks like. Imagine you saw a shoe in the magazine and you want to buy the same shoe. How do you know where to find it? So the solution is often is called image search, and that uses the actual similarity of images as opposed to any kind of a textual description of it. So that's one application. The other one is if you're trying to classify images into different groups. So for example, if you are working on wood processing company and you're processing logs, you want to identify what species of trees that they were made of and maybe what kind of quality to assign to each one. You can also do it in science, for example, identifying types of galaxies or counting the different species of plankton. That might be very critical to understand the health of our ecosystems. These are very difficult problems to automate unless you have the technology for processing images. And finally, in manufacturing, often you're trying to detect anomalies and defects in parts, and you want to do it at high volume, at high speed, and high accuracy. Image featurization and training deep neural nets is actually very difficult. It requires knowledge, it requires highly paid data scientists, lots of hardware, lots of data, and lots of time. So we've made it very easy by supplying those models with our package. And so you can actually take the award-winning ResNet and AlexNet models that we already have trained. We've spent weeks and months of effort to do this, and then they come prepackaged and ready to use. So the way it works is basically that you could take this model and then you can apply it as a featurizer. In other words, it would take an image and produce a set of numeric features, and then you can either search for similar images or you can use a tree or a linear classifier to then solve the problem you're trying to do. Okay, so let's recap.
Sounds good. So to summarize, in April release of Microsoft Machine Learning, we will have support for Hadoop and Spark via ensembling. We will also have a collection of pre-trained deep neural network models, and that includes image featurizers and pre-trained sentiment analysis models. Now, thank you very much.
Thank you so much.